Welcome to Study Loop.
All right, so right now we're going to be looking at a boundary value problem. In this problem, we're going to be looking at how our variables a through d correlate with one another by looking at when our problem has a unique solution, when it has no solution, and when it has infinitely many solutions. Now, before we can delve straight into this, we are going to need to fiddle around a little bit with the equation that we are given. So in the given equation, we have y double prime, y prime, and y. Now, even though these are variants of the same thing, it's going to be a little bit difficult to work with them in the forms that they are currently in. So let's go ahead and convert them into terms of r. Our y double prime will become r squared, our y prime will become r, and our y will just become 1, because we're essentially saying that it is r to the power of 0, which just equals 1. So now that we have our new terms, let's rewrite our equation. It's going to become r squared minus 2r plus 2 equals 0. Now we have two ways that we can solve this auxiliary equation. We could either factor or we could use a quadratic equation. But because of the way that this specific equation is, it's definitely going to be easier for us to just use a quadratic equation. So let's keep in mind while we're doing this that our coefficient for r squared will be our a value. Our coefficient for r, so -2, will be b, and this lovely 2 right here is going to be our c value. So let's solve for r. R is going to equal -b, and our b value in this scenario is -2, plus or minus the square root of b squared, so -2 squared, minus 4 multiplied by a, which is 1, and also multiplied by c, which is 2. And we will divide all of this by 2 multiplied by a, or 1. Let's go ahead and simplify this. -2 is just going to become a +2, plus or minus the square root of 2 squared, -2 squared is going to be 4, minus 4 times 1 times 2, which will become 8. And 2 times 1 is going to be 2. So when we're simplifying now, let's go ahead and separate the two parts of the numerator, since we're able to, since there's a plus and minus separating them. So we will have 2 over 2 plus or minus the square root of 4 minus 8, or -4, divided by 2. Now let's go ahead, before we simplify any further, let's note that this discriminant, the -4, is negative, because this determines which equation we are going to be using, which equation we will be plugging this r value into. So now that we know that we will be using what the book calls a case 3, let's finish simplifying. 2 divided by 2 is 1, plus or minus the square root of -4 is 2i. So we're going to have 2i. 2 divided by 2 is 1. So we will have 1 plus or minus 1i. Now, let's go ahead and note that for the specific equation we are plugging this into, this one right here will become our alpha value, and this coefficient of I, the other one, will be our beta value. So let's plug this into our new equation. We are going to have e to the power of alpha times x, which is 1, so alpha times x, multiplied by the sum of constant 1 times cosine of beta x, and our beta is 1 as well, plus constant 2 multiplied by sine of beta x, so 1x again. Before we set our boundaries to this equation, let's go ahead and simplify it a little bit. So what we're going to do is distribute our e value. We'll go ahead and get rid of the 1s because they aren't particularly important, since 1 times anything is whatever the anything value is. And let's also get rid of our constants, because our constants are not super pertinent to what we are currently doing. So we are going to obtain from this e to the power of x times cosine of x plus e to the power of x times sine of x. Now let's go ahead and create the 2 equations that we will be using to solve a through c based upon our boundaries. So our first boundary is going to set a, the variable a, equal to x. And we're going to set this entire equation equal to c. So let's go ahead and do that. E, instead to the power of x, will be to the power of a, multiplied by the cosine of a, plus e to the power of a, multiplied by the sine of a, will be equal to c. And for our second boundary, we are going to plug our b value, since it is y of b, into x, and set the entire equation equal to d. So we're going to do the exact same thing, but instead of a and c respectively, we'll be doing b and d. So e to the power of b multiplied by cosine of b plus e to the power of b multiplied by the sine of b equals d. So now that we've successfully accomplished setting our boundaries to our equation, let's go ahead and look at a through c. So a is requiring us to look for a unique solution. Let's go ahead and look at what a unique solution even means. If you think about it, when we're dealing with a 2-dimensional plane, it means that there's a unique solution if our given lines only intersect 1 time. That means that our slopes are never going to be equal to one another, because if they're equal to one another, then that means that they're either parallel or they're the exact same line. And we don't want that for a unique solution. So let's go ahead and set e to the power of a multiplied by cosine a to a1, e to the power of b cosine b to a2, e to the power of a times sine a to b1, and e to the b power of b times sine b to b2. And let's write our equation like this. And again, remember, this is essentially saying that our slopes cannot be equal. So a1 over a2 can never be equal to b1 over b2. So let's just go ahead and plug this in now and deal with the algebra involved. We're going to have e to the power of a multiplied by cosine of a over e to the power of b multiplied by cosine of a can never equal e to the power of a multiplied by sine of a over e to the power of b multiplied by sine b. So let's go ahead and make this look a little bit neater. We've got sines and cosines all over the place, so we can deal with tangents instead of sines and cosines. in order to do this, let's multiply both sides of this by e to the power of b multiplied by the sine of b over e to the power of a multiplied by cosine of a. Now, if we're multiplying by both sides, cosine of a is on the top and the bottom, right here and right here. So we can cross those guys out. On this side, it'll still be here. We have e to the power of b multiplied by sine b on the top right here and on the bottom right here, which means that that's going to cancel out. So we will obtain e to the power of b multiplied by sine of b over e to the power of b multiplied by the cosine of b, and excuse me, this is a b right here, is not equal to e to the power of a multiplied by sine of a divided by e to the power of a multiplied by cosine of a. And we know that sine over cosine is tangent, so our final answer for how a and b are correlated for answer A will be that we can have a unique solution as long as tangent of b does not equal tangent of a. Let's move down to question B. Now, when we have no solution, what does that mean on a two-dimensional graph? That is going to mean that our two lines are parallel, because otherwise they would touch, but they are never going to touch. So that means we are going to have the same slope, but they're never going to meet. So we will have a to the power of 1, or I'm sorry, a of 1 over a of 2 is equal to b of 1 over b of 2. Can never equal, and we will be adding our c and d values into this. They can never equal c of 1 over c of 2. And in this case, our c of 1 will be our c value, and our c of 2 will be our d value. So let's go ahead and plug this in. We will have e to the power of a multiplied by cosine of a is over e to the power of b multiplied by cosine of b, I'll write it right this time, is equal to e to the power of a multiplied by sine a over e to the power of b multiplied by sine of b is not equal to c over d. So we are going to want to do the exact same thing, essentially, that we did with problem A. We want to simplify this so that we can deal with more tangents than having these sines and cosines everywhere. So let's go ahead and multiply by the exact same thing that we multiplied with last time. And I will move this out of the way since we will also be using it for problem C so we can have some more room to work. So we're going to multiply this by e to the power of b multiplied by sine of b divided by e to the power of a multiplied by the cosine of a. And again, we're doing this so that we can have sine on the top for this side and cosine on the bottom for this side, so we can make it tangent. The only difference is that now we'll be multiplying with c and d, so we will have this e to the power of b multiplied by sine of b divided by e to the power of a multiplied by cosine of a with the c and the d, but that's okay. So when we do this, e to the power of b, sine b, is at the bottom right here. So we're going to be able to cancel out on this side, and e to the power of a cosine a is right here, so we can cross this out. And we are going to receive the answer. And I'm just going to go ahead and simplify since we did do the math right here already. I'm just going to go ahead and put tangent right off the bat. So our final answer is going to be tangent of b equals tangent of a, but these cannot equal c multiplied by e to the power of b multiplied by sine of b divided by d multiplied by e to the power of a multiplied by cosine of a. And this will be our final answer for if we're looking for no solution. Now moving on to part C. When we're looking at part C on a two-dimensional graph, we are looking at the exact same line. Every single point that exists for this graph is an intersecting point. They're the exact same line. So we want the slope to always meet for this one, which means that we are going to have our a1 value over a2 equal to b1 over b2, and it will be equal to c1 over c2. So interestingly enough, we actually already did all of the math for this when we solved for no solution. The only difference is that our a of 1 over a of 2 and b of 1 over b of 2 is going to equal c of 1 over c2. So let's go ahead and simply drop this answer down and ensure that we make our c1 over c of 2 equal to itself. So we're going to have tangent of b is equal to tangent of a, and it is equal to c multiplied by e to the power of b multiplied by sine of b divided by d multiplied by e to the power of a multiplied by the cosine of a. And we have officially completed this problem.